This is question number 2, component 12. This question says the identify each of the following with one laboratory test. So component, these are the different classes of organic compounds: alkene, alcohol, phenol, and aldehyde. So let's see one by one. Identification of alkene. There are several ways to identify alkene in laboratory test. And one of them that is very important is halohydration. Halohydration means this is the addition of bromine and OH simultaneously on adjacent carbon atoms of alkene or the sp2 carbons of alkene. So how it identifies, first see the chemical equation. In this equation you can see that aqueous bromine is taken aqueous because it is in water. So what happens? Bromine is brown in color. So when this reaction occurs, the color of bromine discharges. This is brown in color, and this color discharges if reaction occurs because there is no any brown color or the orange color compound. But here bromine itself is brown in color. So remember that how this reaction is performed, although it was not required here, but as I'm explaining, so I should do this. So first we take the sample of alkene here, and then we add 1 to 2 drops of aqueous bromine. So a few drops of bromine when added, so the color of bromine you will see it will disappear. And why disappear, I have explained here already. Now identification of alkene is continued by a second method. This is also with the bromine, same result will be obtained, but here the solvent would be hexane, carbon tetrachloride, or chloroform, and the result is same. Just the difference is that here in test tube, you will take the solution in any of these inert solvent, which neither act as uh, nucleophile nor base or any other reaction to the alkene. So that's why they are called the inert solvent, and these are the non-polar compound. So the difference is that in previous case that you have seen, we obtain this compound, that is the bromohydrin. The name of this compound is bromohydrin. It is written here. But here the observation would be same, that the brown color of bromine discharges, but the product is different. It is 1,2-dibromoethane, and inert solvent is used instead of water. So the brown color of bromine discharges. So we can use either of these two tests depending on the availability in the laboratory. Now see the identification of alcohol. Just like alkene, there are several ways to identify an alcohol, and I have given here two methods. Test with sodium metal. When alcohols reacted with sodium metal, when you take the pure alcohol in the test tube and you take, this is an alcohol, and when this alcohol, in this alcohol we add a small piece of sodium metal. So what happens? It produces hydrogen gas. So you will see the brisk effervescence evolving from there. So it almost confirms the presence of hydrogen gas. But remember that because acid can also give the reaction. So better to collect this gas in another test tube, another empty test tube, and bring the ignited splint or the matchstick, then it will give the pop sound. So actually, these are the simultaneous identification of alcohol as well as the hydrogen gas. So hydrogen gas is produced. So if hydrogen gas is produced, it means this compound would be an alcohol. But remember that a single test is not enough in organic compounds to identify any group of any class of the organic compound. So we have to perform at least 1 to 2 reactions. So anyway, in this reaction, you can suggest this reaction in the answer. Next is the esterification test. In esterification, alcohol is treated with any carboxylic acid, and the most available carboxylic acid is ethanoic acid, that is also known as acetic acid. So it is available, most available compound, and comparatively cheap as compared to other carboxylic acid. So we use this, and we reflux with the concentrated sulfuric acid that is used as catalyst, and this is a reversible reaction. So in presence of concentrated acid, when we react our sample compound, the given compound with acetic acid, ethanoic acid, then it produces methyl ethanoate that gives fruity smell. So if you are performing this test in the laboratory, then better to transfer the content of your test tube after refluxing in a china dish. So when you transfer this into the china dish, then surface area would be greater. So more vapors of the ester will be evaporated. So the fruity smell can be observed clearly. So fruity smell of ester is indicate the presence of alcohol. Now see, the fourth option is the identification of phenol. Again, we have two different tests for phenol. You can use any one of them in the laboratory as well to answer this question. We don't need to write both the answer because they have asked to answer any one laboratory test. So one of the tests is the ferric chloride test. How do we perform this test? We take the sample of organic compound or its solution. Then we add a few drops of ferric chloride solution, aqueous ferric chloride. So it is very light yellow in color, ferric chloride solution. So this yellow colored solution turns into different color, blue, violet, purple, or any other color. If this color changes occurs, then it indicates the presence of phenol. But remember that this color may be changed due to any other group which are not phenol. So this is not very reliable test in the laboratory, but as in our syllabus, it is given one of the tests. So it is true where if you write this test for identification of phenol. So anyway, uh, this is one of the tests that you can write in the answer of this question. So actually what happens when it reacts with ferric chloride, iron is a transition metal, so it can form complexes with organic ligands. So phenol or the phenoxide ion act as act as a ligand. So it forms an octahedral complex, and this complex has a particular color, and that color is specific for different types of phenols. You know, The most common phenol is this. It's the phenol. But when we use the term phenols, then there are different phenols. If any aromatic compound has OH, for example, if OH is on to adjacent position in benzene ring, this is called catechol. It gives different color, and phenol gives different color. This is monohydric, this is dihydric, and another dihydric phenol is this. So you have seen different types of phenols in the chapter. So this is resorcinol, this is catechol, this is simple phenol, and all of these phenols and other phenols as well, they give a particular color. So it could be violet, blue, purple, even it could be red if there is a complex, if multiple groups are there along with the phenol. Anyway, we shouldn't go in more detail. You just focus on the point that this test can be used for identification of phenol in the laboratory. So what we do, we take the sample solution and we add a few drops of ferric chloride solution, aqueous solution. Then the color of, if phenol is there, then the color changes from violet, blue, purple, or any other color. And I have already told you that this test alone is not enough to confirm the presence of phenol. You don't need to write it in your answer, but because I'm explaining in the video, so I'm telling you everything. Now the bromine water test is carried out here again for phenols, but the results are different. This is not addition of bromine, but here the aqueous bromine when react with phenols, this simple hydroxybenzene. So what happens? It produces 2,4,6 tribromophenol. This is the polysubstitution of bromine that you have learned in the chapter. So this is the this product is actually the white precipitate. So color changes from brown color of the bromine discharges and white precipitates appear. So the disappearance of brown color and formation of white precipitates indicate the presence of phenol. So actually what happens when we perform this test in the laboratory? So initially we will see that the solution is brown in color. Not this solution. This solution is usually colorless, but the drops of aqueous bromine when you add this is brown in color. So when you add this, then there would be no brown color. This brown color disappear here, and you will observe the white precipitate throughout the test tube which settle down after a few minutes. So this is the observation that brown color of bromine disappears while white precipitate appears. So it shows the presence of phenol. Now this is the last component, that is the identification of aldehyde. We know that aldehyde and ketones are carbonyl compounds. Although the test for carbonyl compound is 2,4 dinitrophenylhydrazine test that gives orange precipitate or yellow precipitate. But when you are to distinguish between an aldehyde and ketone, so aldehyde gives these tests, but ketone does not. The first one is the silver mirror test or the Tollen's reagent test. Tollen's reagent is a mixture of silver nitrate and ammonium hydroxide. So we say that Tollen's reagent is an ammonium, silver nitrate. So what we do, Again, we take the test tube, and in the test tube, we take a solution, sample solution, and in this sample solution, we add Tollen's reagent. This reagent is added to the test tube about the same volume as it was the volume of the sample. Then we mix it and reflux in the water bath about 70 to 80 degrees Celsius. So when the sample containing aldehyde is heated with Tollen's reagent, aldehyde reduces the silver ions into silver metal, and that silver metal deposits on the fine smooth surface, and the surface, inner surface or the outer surface, but definitely silver is inside, so the inner surface is coated with silver due to the deposition of silver metal that form silver mirror. So you can see the equation here. Silver is in +1 form, and now it has zero charge. So definitely if it is going from plus to zero, it is the reduction process after gaining the electron. So here aldehyde act as a reducing agent, and this American silver nitrate acts as a mild oxidizing agent. So what happens? We produce this ammonium salt of the carboxylic acid. Actually, this aldehyde is converted into carboxylic acid. If this is methanol, then the methanoic acid. If it was ethanol, then it would be the ethanoic acid. So the respective carboxylic acid is obtained along with the liberation of ammonia gas, and water is produced. So this test can be used to distinguish between aldehyde and ketone, as well as for identification of an aldehyde. So this is the silver mirror, and the formation of silver mirror indicates the presence of an aldehyde. So it was one of the tests. And another test that we carry out for identification of aldehyde is the Fehling test. Here we take the Fehling solution, and Fehling solution or the Fehling reagent is actually comprises two solutions. One is the Fehling solution A, that is the aqueous solution of copper sulfate. Usually the 5% copper sulfate is this. And another one is the Fehling solution B, that is the mixture of aqueous sodium potassium tartrate and the aqueous sodium hydroxide. So what happens actually, this is the blue in color, and in reality, in presence of tartrate, these ions are available in solution. So copper ions, copper 2 plus ions are converted into copper 1 plus. So it is going from 2 plus to 1 plus, so it is the reduction. So due to this reduction process, we obtain the copper 1 oxide. It is red in color. And we obtain the carboxylic salt, respective carboxylic salt, because it is an alkaline medium. So definitely instead of acid, we obtain the salt. So we obtain the red PPT of this compound. How it is performed, see here. First we take a sample solution, and then we add the solution A, Fehling A, almost the same quantity. And after taking solution A, we take solution B, sample solution, not sample, Fehling solution B. And after that, we reflux. So what will you see in the test tube? That first it changes to green color, then yellow color, and finally we we see the red color. It depends on the concentration of aldehyde If you take the small quantity of aldehyde, then the color obtained that at the end of the reaction after 5 minutes, it would be orange instead of red. So either of the color, green, yellow, or red, it shows the positive Fouling test. And positive Fouling test means there could be an aldehyde. But remember that Fouling test and Tollen's reagent test, these are not only for aldehyde, but also for reducing sugar. Both of these tests are positive in case of reducing sugars. What are reducing sugar? Definitely you have learned in your biochemistry chapter number 10. Okay. So, but right now we have to give the test, laboratory test for identification of aldehyde. So answer is the same. So that's all for this question. Now we will again see another question in the next video.